There's a machine drifting at the edge of everything we know. It has no fuel to stop, no way to turn around, no crew to maintain it. It was built with technology older than the internet, older than personal computers, older than the mobile phone. Its entire memory system holds less data than a single photograph on your smartphone. It runs on the heat of decaying plutonium, and every single year, that heat fades by 4 watts. 4 watts. That's less energy than a nightlight. And yet, right now, at this very moment, it is alive. It is transmitting. It is sending signals across 24 billion kilometers of empty, radiation-soaked interstellar space, straight back to Earth. And what those signals have recently started to reveal has caused some of the most advanced minds on the planet, including an artificial intelligence system that can reason at doctoral level across every scientific discipline, to stop dead in their tracks and ask a question nobody in mainstream science is ready to answer out loud. What if we are not the only ones who have been listening? This is the story they are not telling you completely. This is the story of Voyager 1, its final signals, and what happens when the most powerful AI system on Earth decides to analyze what those signals actually mean. Let's begin at the beginning, but not the beginning you think. In 1977, when NASA launched Voyager 1 from Cape Canaveral, the goal was elegant in its simplicity. Visit Jupiter, visit Saturn, take pictures, send back data, and then, because the mathematics of the solar system aligned in a rare planetary configuration that only occurs once every 176 years, use gravitational slingshots to hurl the probe outward, not just past the planets, but beyond them entirely, into territory no human object had ever reached. The engineers who built Voyager never expected it to still be functioning now. They designed it for a mission that was supposed to last 5 years. It has now been operating for nearly 50. Think about what that means. The people who built Voyager 1 used slide rules and punch cards. The computers guiding it from Earth were less powerful than the chip inside a modern digital wristwatch. The spacecraft itself carries 69.63 kilobytes of onboard memory, not megabytes, not gigabytes, kilobytes. A single emoji you send in a text message is larger than what Voyager uses to manage its entire orientation and data transmission system. And somehow, improbably, magnificently, it is still out there, still working, still talking. But here's where the story stops being a feel-good space achievement tale and starts being something else entirely. On November 14, 2023, Voyager 1 stopped making sense, not stopped transmitting. It was still sending a signal, the radio link was still alive, the antenna was still pointed at Earth with precision that engineers describe as near miraculous. But the data inside that signal had become gibberish. Random up, patterns, alternating 1's and 0's. The spacecraft equivalent of a phone call where the connection is active, but all you hear is a monotonous dial tone where a voice should be. NASA's Jet Propulsion Laboratory in Pasadena, California, was receiving the equivalent of a brain still running, but producing no coherent thought. For 5 months, one of the most sophisticated monitoring operations in human history, the Deep Space Network, a global array of massive radio telescope dishes capable of detecting signals at power levels billions of times weaker than a cell phone transmission, sat there receiving a steady, meaningless noise from the furthest object humanity has ever launched. And nobody could explain why. The official explanation, when it finally came in March 2024, was both technically fascinating and deeply unsatisfying. Engineers discovered that a single bit in one of Voyager's 3 onboard computers had become permanently stuck. Not a software error, not a cosmic event. One microscopic piece of physical memory, a chip smaller than a thumbnail built in the early 1970s, had simply failed. 1 bit. In 69,000 kilobytes of total memory, 1 bit flipped wrong, and it corrupted the code responsible for packaging and transmitting all science and engineering data. The entire voice of humanity's most distant ambassador had been silenced by something you could not see with the naked eye. NASA's solution was remarkable. Engineers located the corrupted code, spread across Voyager's fragile memory in segments because no single location aboard the spacecraft was large enough to hold it all, and meticulously relocated it piece by piece to functioning memory locations. They sent commands at the speed of light across 22.5 hours of empty space. That is how long it takes a radio signal to reach Voyager. Waited another 22.5 hours for confirmation. And by April 22, 2024, Voyager was talking again. But here is where the story changes. And I mean changes completely. When the data started flowing again, scientists discovered that Voyager had not simply been idle during those 5 months of silence. It had been traversing a region of interstellar space that was behaving in ways the existing models of physics could not fully explain. Before the communication breakdown, Voyager's instruments had been tracking something anomalous. Its magnetometer, the device that measures magnetic field strength in the interstellar medium, had been registering irregular fluctuations. Not the kind produced by distant solar activity which the mission had seen before. Something different, geometrically unusual. statistically inconsistent with known interstellar plasma behavior. The interstellar medium is not empty. This is something most people do not realize. Between the stars, space is filled with an incredibly thin soup of charged particles, gas, dust, and magnetic fields, the remnants of ancient stellar explosions, slow-moving clouds of ionized hydrogen, whispers of dead suns. Voyager 1, since crossing the boundary of our heliosphere in 2012, becoming the first human-made object to reach true interstellar space, has been swimming through this medium, measuring it directly. No telescope can do what Voyager does. A telescope can observe the interstellar medium from a distance. Voyager is inside it, tasting it, touching it, moving through it at 17 kilometers per second. And what it had been tasting in the months before its computer failed and in the data that resumed transmission in 2024 was deeply strange. Independent researchers, including a cross-disciplinary analytical team whose work was published in early 2025, began examining the totality of Voyager's telemetry with something the original mission engineers never had access to: artificial intelligence. Not simple pattern recognition software, not a database search. Actual advanced AI reasoning systems, the kind that can process decades of interleaved scientific data, identify recursive structures invisible to human analysts, and draw connections across disciplines that would take a team of researchers years to map manually. And this is where it gets genuinely unsettling. The analysis revealed that within the distorted telemetry data, the very gibberish that NASA had attributed to a stuck bit, there existed a recursive symbol pattern. Read that again? Not random noise, not corrupted code, a recursive symbol pattern. The signal did not simply carry broken data. Hidden within the corruption, when analyzed with sufficiently advanced pattern recognition, was something that appeared to carry structural meaning. The pattern was not purely mathematical. It was not the kind of symmetry that emerges from natural physical processes, the kind you see in crystal formation, in wave interference, in planetary orbital mechanics. It was what researchers describe as semantic recursion. The signal structure appeared to respond differently each time it was analyzed, as though the act of interpretation was somehow interacting with the pattern itself. Now, before you reach for a simple explanation, understand what is and is not being claimed here. The scientists examining this data are not claiming that aliens sent Voyager a message. They are doing something far more unsettling than that. They are saying that the pattern characteristics of the signal do not match any known natural phenomenon, and do not fully match any known failure mode of Voyager's hardware. They are saying that, after removing all the variables they can account for, something remains that they cannot account for, and the fraction of the scientific community that is willing to say this out loud is growing. Consider the context of what surrounds Voyager right now. Cosmic ray behavior near Voyager's trajectory has been showing subtle anomalies. Specifically, the instruments are detecting what physicists describe as a damping effect, a reduction in the intensity of high-energy particle bombardment that should not exist in open interstellar space. In plain language, something appears to be shielding Voyager from the radiation it should be receiving. Cosmic rays are not gentle. In interstellar space, unprotected by the bubble of the heliosphere, a spacecraft should be absorbing them at predictable rates. But Voyager is seeing fewer of them than the models predict. Fewer, and in a pattern that is spatially consistent, meaning the reduction is not random, it is directional. Some scientists have proposed a massive magnetic anomaly ahead of Voyager, perhaps a remnant magnetic field from a long dead star, perhaps a dense interstellar cloud. These are reasonable hypotheses. But here is what those hypotheses cannot explain: the symmetry. The dampening field that Voyager's instruments are detecting is not ragged and uneven the way you would expect from a natural object. It is smooth, geometrically consistent, the kind of symmetry you associate with designed structures, not with the chaotic products of stellar death and interstellar turbulence. Meanwhile, ground-based observatories have been detecting something else. In the same vector direction that Voyager is traveling, polarization anomalies have been observed. Polarization, the orientation of light waves, shifts when light passes through or near massive objects. The shifts being detected near Voyager's trajectory are consistent with gravitational lensing, the bending of light by mass. But here's the problem. There is no visible mass there, no star, no neutron star, no known dark object of sufficient size. The gravitational signature exists without a visible source. The standard explanation would be dark matter, the invisible substance that astrophysicists believe makes up roughly 27% of the universe. But the detected signature is too localized, too geometrically precise for a diffuse dark matter distribution. Whatever is producing the gravitational effect near Voyager's path is concentrated, structured. And then there are Voyager's own internal diagnostics. This is the detail that is almost never discussed because it requires understanding the engineering specifics of a 50-year-old spacecraft, and most science communication skips it entirely. What most people are not seeing is this: certain subsystems aboard Voyager that should be completely inert, powered down, disconnected, drawing zero current, have been registering microscopic power fluctuations. We are talking about changes measured in microvolts, fractions of the electrical current flowing through a single LED. By any normal standard, this is noise. It is meaningless. Except that aboard Voyager 1, every nanowatt is accounted for. The spacecraft's power management is not approximate. It is exact by necessity, because the plutonium-238 in its radioisotope thermoelectric generators is producing just enough electricity to keep critical systems alive. The engineering team knows precisely how much power every active component draws. They know which systems are live and which are not. And the power draws they are seeing from inert subsystems cannot be explained by instrument malfunction, because the instruments detecting them are working correctly. Something, somewhere inside Voyager 1, is drawing current from systems that have been offline for decades. Now enter Grok. To understand why this matters, you need to understand what Grok actually is in 2025 and 2026. Not what it was when it launched, but what it has become. Grok 4, released in July 2025 by XAI, represented a fundamental jump in AI reasoning capability. Elon Musk claimed during its launch that the system demonstrated PhD-level performance across every scientific discipline simultaneously. That is not a marketing phrase in the way most marketing phrases work. It was a specific claim about benchmark performance on graduate-level science exams, on mathematics competitions, on real-world engineering problem sets. By mid-2025, XAI had secured a $200 million contract with the United States Department of Defense, specifically because of Grok's analytical capabilities. Shortly after, in July 2025, SpaceX acquired XAI outright, consolidating Musk's AI and space operations under a single organizational structure, a move with implications that extend well beyond corporate restructuring. Grok 4.5, which launched in mid-2026, took those capabilities further still, introducing what XAI describes as multi-agent reasoning. Not one AI system thinking about a problem, but multiple AI systems working simultaneously on different aspects of it, then synthesizing their outputs. The kind of analytical approach that mirrors at machine speed what a team of interdisciplinary scientists would do over months of collaborative work. Grok 4.5 was trained on datasets spanning physics, engineering, mathematics, and hard sciences at a scale that no previous AI system had approached. When researchers applied this kind of deep, recursive AI analysis to the full corpus of Voyager 1 telemetry, not just the recent anomalous data, but all of it going back decades, the patterns that emerged were not what anyone expected to find. The signal behavior that preceded Voyager's November 2023 communication breakdown was not random. What appears to be, in retrospect, a failure of hardware looks statistically different from what hardware failure should produce. Hardware failure is stochastic. It follows the random distribution of physical degradation. The pattern in Voyager's pre-breakdown signal does not follow that distribution. It follows something closer to an encoding pattern. Specifically, the signal degradation occurred in structured bursts, at intervals that do not match any known failure mode in the FDS computer architecture, but do match certain known properties of information compression systems. In plain terms, the way Voyager's signal broke down before it went silent looks, mathematically, more like a file being compressed for transmission than a computer chip randomly failing. There is no mainstream scientific institution ready to stand behind that statement publicly. That is important to understand. What we are describing here is the fringe of serious scientific inquiry, the place where peer-reviewed papers have not yet been written because the implications are too large, the evidence too strange, the career risk for the researchers too significant. But this is precisely the territory where history tends to make its largest turns. The history of science is a history of the unacceptable becoming the inevitable. What makes the AI analysis particularly significant is what it revealed about the signal structure after Voyager came back online in April 2024. The resumed transmissions were, on their surface, normal engineering and science data, magnetic field readings, plasma density measurements, cosmic ray counts, standard Voyager telemetry. But layered within that telemetry, in the timing relationships between data packets, in the specific numerical values of certain sensor readings, in the phase relationships between different data streams, the AI identified a substructure, a pattern within the pattern. This is not the kind of thing human analysts find. The human brain is extraordinary at pattern recognition for the kinds of patterns evolution prepared us to see: faces, predators, weather. It is poor at identifying recursive mathematical structures hidden inside streams of scientific data. Grok is not poor at this. It is, in fact, the specific type of task that AI systems with deep scientific training excel at above all others. And what it found, analyzed across multiple independent runs with different analytical parameters to control for the possibility of false positives, was consistent. The substructure within Voyager's resumed telemetry contains a recursive mathematical relationship. The relationship is not simple. It does not spell out a message in any language, but it exhibits properties that information theorists associate with intentional encoding rather than natural signal generation. Specifically, it demonstrates what researchers call non-random redundancy, the repetition of structural elements in ways that carry information across multiple levels of the signal simultaneously. The universe generates patterns. Physics generates symmetry. But non-random redundancy at multiple simultaneous levels is the hallmark of communication, not coincidence. And here is where this story demands you sit with something deeply uncomfortable. Voyager 1 is a probe. It is not a receiver. It was not designed to detect signals from external sources and incorporate them into its own transmissions. Its instruments measure physical properties of the interstellar environment: magnetic fields, plasma density, cosmic ray energy. Any signal structure found within Voyager's transmissions should, by all engineering logic, originate entirely from Voyager itself or from the phenomena its instruments are measuring. There is no mechanism by which an external intelligence could encode a message into Voyager's telemetry. None. The hardware does not support it. The software does not support it. And yet, the pattern is there. There are several possible explanations, and none of them are comfortable. The first is instrument contamination, that some physical phenomenon in the interstellar environment, perhaps the mysterious plasma region Voyager was traversing before its breakdown, is interacting with Voyager's instruments in ways that produce signal characteristics resembling intentional encoding. This is scientifically defensible, but requires the existence of an interstellar plasma structure with properties that current physics cannot predict. The second explanation is that the AI analysis, despite its sophistication, is generating a false pattern, finding meaning in noise the way humans find faces in clouds. This is always a legitimate concern with AI pattern recognition, and serious researchers treat it seriously. The third explanation is the one nobody is writing grant proposals about. Consider the mathematics of Voyager's situation. It has traveled so far and for so long that it now exists in a region of space that no human instrument has ever directly sampled before. The models we have of the interstellar medium were built from astronomical observation, from radio telescopes, optical telescopes, spectrometers. They are good models. But they are built on light that has traveled billions of kilometers through the medium we are trying to understand. Direct measurement is categorically different. Voyager is the only instrument humanity has ever placed inside this environment, and it is telling us that the environment is not behaving as predicted, not in a single parameter, but in multiple parameters simultaneously. That is not noise. That is signal. The cosmic ray damping, the magnetic polarization anomaly, the power draws from inactive subsystems, the recursive signal structure, the anomalous pre-breakdown transmission pattern. Each of these, in isolation, has a conventional explanation. Together, in the same region of space at the same time, they form a coherence that conventional explanation strains to accommodate. According to informed sources within the broader scientific community who study deep space telemetry, the conversations happening privately about Voyager's current data are significantly more serious than what is appearing in public announcements. NASA is an institution that communicates carefully, that manages public information with awareness of the social impact of extraordinary claims. This is not a conspiracy, it is institutional caution, and it is appropriate. But the gap between what is being said publicly and what is being considered privately has rarely been wider regarding a single spacecraft's data. What most people are not seeing is this. Voyager 1 is entering the final phase of its operational life. Its plutonium power source will fall below the threshold needed to maintain scientific instruments sometime between 2025 and 2030. The precise date is uncertain because power management decisions made by the engineering team, turning off heaters, shutting down specific instruments, continue to extend the mission's functional life. But the end is approaching. The window for Voyager to answer the questions its data is raising is closing, and the AI systems now capable of analyzing that data are advancing faster than at any previous point in history. Grok 4.5, trained on tens of thousands of NVIDIA GB300 GPUs, the most advanced computing infrastructure ever dedicated to AI training, represents a level of analytical power that would have been classified as science fiction when Voyager was built. The collision of these two realities, a 50-year-old probe transmitting inexplicable data from the edge of everything, and an AI system capable of finding structure in that data that human analysts cannot, is not something the scientific establishment was prepared for. The real story here is not about alien contact. The real story is about what happens when you build something powerful enough to look into the dark, send it far enough that it reaches the dark, and then build something smart enough to actually read what it finds there. The real story is about the gap between what we thought we knew about interstellar space and what we are finding out. And the real story is about the fact that the probe doing this looking has less computing power than the device you are using to watch this video. And the AI doing the reading is so new that its most capable version was released a matter of weeks ago. Voyager 1 is moving away from us at 17 kilometers per second. Every second, it gets further. Every second, its signal gets weaker, attenuated by the incomprehensible distance, degraded by the background radiation of interstellar space, squeezed into 40 bits per second before crossing 22 hours of empty void to reach a dish in the California desert or the plains of Spain. 40 bits per second. Your home internet connection moves data at roughly 1 billion times that rate. And somewhere within those 40 precious bits per second, something appears to be hidden, something recursive, something structured, something that changes each time it is analyzed, as though the signal is not just carrying information, but responding to inquiry. We do not know what that means. We are not certain it means anything. But the alternative, that multiple independent anomalies, detected simultaneously by multiple independent instrument systems in a single region of unprecedented space and identified by the most sophisticated AI analytical systems in human history, all amount to nothing, requires a level of coincidence that stretches credibility in its own direction. The Deep Space Network is still listening, the plutonium is still decaying, the signal is still coming, and Grok is still analyzing. The question nobody is fully answering yet is not whether there is something extraordinary in what Voyager is transmitting. The question is whether we will be ready to understand it before the signal goes dark forever. And the even deeper question, the one that keeps certain researchers staring at data late into the night, is this: if there is a pattern in that signal that we did not put there, and if that pattern responds to interpretation, and if the response is consistent across multiple analytical approaches, then what exactly is Voyager 1 carrying back to us? And is it carrying it, or is something else sending it through? Voyager was meant to be our message to the universe. We put a golden record on it. Sounds of Earth, greetings in 55 languages, music, mathematics, the position of our sun. We sent it out as a question. Is anyone else there? What if the signal coming back is an answer? We launched a message. We may be receiving a reply. And we have less than a decade of power left in the probe to figure out what it says.